Hello everyone, welcome back to our channel Problematical. We were discussing about, in the last class we discussed exercise 2.1. Today we'll discuss exercise 2.2 of chapter 2 Polynomials from class 9th Maths NCERT. The first question says, to find the value of polynomial 5x minus 4x squared plus 3. So our given polynomial is 5x minus 4x squared plus 3. I'm calling it P of x. And since this is my assumed variable or a notation, hence I'll write say. It is equivalent to saying let P of x is equals to the given expression. So this is your P of x. You have to find this expression's value at a specific value of x is equals to 0. At x is equals to 0, P of 0 will be equals to 5 into 0 minus 4 into 0 square plus 3. These two terms will be 0. You're left with 3. That's your answer. At second value, x is equals to minus 1. So wherever there's an x, we'll substitute equals to minus 1. 5 into minus 1 minus 4 into minus 1 whole square plus 3. This is minus 5 minus 4 into minus 1 square, 4 into 1, 4 plus 3. So this is minus 9 plus 3, which is equals to minus 6. Lastly, you have to find out the value at x is equals to 2. So at x is equals to 2, P of 2 will be equals to 5 into 2 minus 4 into 2 square plus 3. 5 into 2, 10 minus 4 into 2 square is 4. 4 into 4 is 16 plus 3. Addition first, this is 13 minus 16, which is equals to minus 3. So the answer of P of 0, let's write it in a box. P of 0 is 3. P of minus 1 is minus 6. This is equals to P of 2. Put them into the box. Next, find P of 0, P of 1, and P of 2 for each of the following expressions of polynomial. Solution. In the first case, P of y is equals to y square minus y plus 1. You have to find the value of P of 0, P of 1, and P of 2. So P of 0 is equals to 0 square minus 0 plus 1. This is equals to 1. P of 1 will be equals to 1 square minus 1 plus 1. So this is also equals to 1. P of 2 will be equals to 2 square minus 2 plus 1. 2 square is 4. 4 minus 2 is 2. 2 plus 1 is 3. Next. P of t is equals to 2 plus t plus 2 into t square minus t cube. This is your given polynomial. Therefore, P of 0 will be equals to 2 plus 0 plus 2 into 0 square minus 0. These terms are 0. You're left with 2. P of 1 is equals to 2 plus 1 plus 2 into 1 square minus 1 cube. This is equals to 2 plus 1, 3. 3 plus 2, 5. 5 minus 1, 4. Next, P of 2. P of 2 is equals to 2 plus 2 plus 2 into 2 square minus 2 cube. This is equals to 4. 2 square is 4. 4 into 2 is 8. So plus 8 minus 2 cube is 8 minus 8. These should get cancelled. You're left with 4. Next polynomial is P of x is equals to x cube. Therefore, P of 0 will be equals to 0 cube, which is 0. P of 1 will be equals to 1 cube, which is 1. And P of 2 will be equals to 2 cube, which is equals to 8. Next, your fourth value is P of x is equals to x minus 1 into x plus 1. Therefore, P of 0 will be equals to 0 minus 1 into 0 plus 1, which is minus 1 into plus 1, which is minus 1. P of 1 will be equals to 1 minus 1 plus 1. This is 0 into 2, which is 0. P of 2 will be equals to 2 minus 1, 2 plus 1. This is 1 into 3, which is equals to 3. Next, verify whether the following are zeros of the polynomial indicated against them. This means that your first is an expression and this is the value of x. We have to check whether minus 1 by 3 is the zero of P of x. If you substitute x is equals to minus 1 by 3 in P of x, you should get a 0. A 0 indicates that it is a ZERO 0. If it is a non-zero term, P of x, then x is equals to minus 3 or minus 1 by 3 is not a ZERO 0 of the given polynomial P of x. Let's check for the given values. First, P of x given is equals to 3x plus 1 at x is equals to minus 1 by 3. P of minus 1 by 3 is equals to 3 into minus 1 by 3 plus 1. 3 gets cancelled. You're left with minus 1 plus 1, which is equals to 0. This is P of minus 1 by 3. Since P of minus 1 by 3 is equals to 0, therefore minus 1 by 3 is 0 of P of x. Next, P of x is equals to 5x minus pi. You have to check whether this is a whether x is equals to 4 by 5 or 4 by 5 is a 0 of P of x. So at x is equals to 4 by 5, the P of 4 by 5 will be equals to 5 into 4 by 5 minus pi. 5 will be cancelled. We're left with 4 minus pi, which is not equals to 0. Therefore, 4 by 5 is not 0 of P of x. Next given, P of x is equals to x square minus 1. If this is the case, then x is equals to 1. There are two values of x given over here. X is equals to 1 and x is equals to minus 1. You have to check for both the values. At x is equals to 1, P of 1 is equals to 1 square minus 1, which is equals to 0. At x is equals to minus 1, P of minus 1 will be equals to minus 1 whole square minus 1, which is equals to 1 minus 1, which is equals to 0. Therefore, 1 and minus 1 are zeros of P of x. Next, your fourth value is P of x is given as x plus 1 into x plus 1 into x minus 2. At x is equals to minus 1, the P of minus 1 is equals to minus 1 plus 1 minus 1 minus 2, which is, this is 0, 0 into minus 3, which is 0. You also have to check for 2. So at x is equals to 2, P of 2 is equals to 2 plus 1, 2 minus 2, this is 0, this is 3 into 0, which is 0. Therefore, both minus 1 and 2 are zeros of P of x. Next. Fifth, P of x given is x squared. You have to check at x is equals to 0. So at x is equals to 0, P of 0 will be equals to 0 squared, which is 0. Therefore, 0 is 𝐢𝐬0 of P of x. Next, P of x is equals to Lx plus m. And you have to check at x is equals to minus m upon L. At this value, the P of minus m upon L will be equals to L into minus m upon L. L will get cancelled, plus m. This is minus m plus n, m. These two will get cancelled and you're left with 0. Therefore, minus 1 upon m upon L is the 0 of P of x. Next. P of x given over here is 3x squared minus 1. And you have to check at x is equals to minus 1 upon root 3. Here it should be root 3. Plus 1 by root 3. Then plus it should be minus. Minus 1 by root 3 and plus 2 by root 3. So at minus 1 by root 3, P of minus 1 upon root 3 is equals to 3 into minus 1 upon root 3 whole square minus 1. This is 3 into 1 upon 3 minus 1, which is 1 minus 1, which is 0. Next, at x is equals to 2 upon root 3. The P of 2 upon root 3 is equals to 3 into 2 upon root 3 whole square minus 1. This is 3 into 4 by 3 minus 1, which is equals to 3, which is not equals to 0. Therefore, minus 1 upon root 3 is the root of P of x, but 2 upon root 3 is not the 0 of P of x. Root is also called as 0. Next, P of x is equals to 2x plus 1 at x is equals to 1 by 2. P of 1 by 2 will be equals to 2 into 1 by 2 plus 1. This is 1 plus 1 equals to 2, not equals to 0. Therefore, 1 by 2 is not the root or 0 of P of x. Fourth question is, find the 0 of the polynomial in each of the following cases. Now, to find the 0 of the polynomial, all you have to do is equate P of x is equals to 0. Whatever value of x you get is your 0 of the polynomial. So, P of x is equals to x plus 5. P of x is equals to 0. X plus 5 is equals to 0. X is equals to minus 5. Therefore, minus 5 is the 0 of P of x. Next, 1 second. Okay. Second, P of x is equals to x minus 5. So you equate P of x with 0. X minus 5 will be equal to 0. Your x value will be equals to 5. Therefore, 5 is the 0 of P of x. Observe that all the values given in this question are linear polynomials. So you'll get only 1 0 for each of these values, each of these polynomials. P of x is equals to 2x plus 5. Equating P of x with 0, you have 2x plus 5 is equals to 0. Therefore, x is equals to minus 5 by 2. Therefore, minus 5 by 2 is the 0 of P of x. Fourth, P of x is equals to 3x minus 2. P of x is equals to 0. Therefore, 3x minus 2 is equals to 0. Therefore, x is equals to 2 upon 3. Next, fifth value is P of x is equals to 3x. P of x is equals to 3x. Equating P of x with 0, you get 3x is equals to 0, which means that x is equals to 0. Therefore, 0 is the 0 of P of x. Next, P of x is equals to ax, where x is not equals to 0. Therefore, equating P of x with 0, you have x is equals to 0. Therefore, 0 is the 0 of P of x. P of x is equals to cx plus d, such that c is not equals to 0 and both c and d are real numbers. Therefore, equating this with 0, you get cx plus d is equals to 0. Cx is equals to minus d. X is equals to minus d upon c. Therefore, minus d upon c is the 0 of p of x. You can substitute whatever answer you've got again into p of x and verify whether you're getting a numerical 0 or not. This concludes this exercise. Thank you.